Okay. How to graph a quadratic. So, let's say we're given a quadratic. Y is equal to negative x squared plus 8x minus 7. And I want to graph this. Okay? The great thing about graphing this equation is it's not that difficult as long as you use the right points. How many points does it take to draw a line? 2. Good. How many to draw a curve? 3. Depending on the type of curve, right? Now, how many to draw a perfect parabola? It takes 3 perfect points. And I'll show you what I mean by that. Now, if you talk about something that's a cubic, you're going to need 4 perfect points. Okay? And something raised to the 5th power, a 5th degree polynomial, you're going to need 5 perfect points. Okay? Or no, sorry about that. If it's raised to 2, you need 3 perfect points. If it's a cubic, you need 4 perfect points. And if it's raised to the 4th, you need 5 perfect points. So if it's raised to the 5th, you need 6 perfect points. And you're like, what is... I see a pattern coming, but why? Okay? Well, here's the deal. When we deal with this cubic, or this quadratic, what we want to do is first understand some certain things about it. Okay? Every quadratic can be labeled as such. They all are in 2 shapes. They either look like this, or they look like this. They're either happy or they're sad. Okay? If the first coefficient is negative, then they're sad. If the first coefficient is positive, then they're happy. Okay? So right off the bat, I know that this is sad. So I'll put a little thing showing me, okay, this one's sad. You know?
So when it asks which direction does the graph open,
yeah,
it would be downward?
It would be downward. Okay. Yeah. Okay? Now I want to say, okay, I know it opens downward. What else do I want to know about it? Well, I need to know some specific points. These points, I need points on the outside, but I need one very, very, very important point. And that point is this top point, right here. And what happens at this point? Well, all parabolas are symmetrical. That means they're the same on one half as they are on the other half. Kind of like us. We're actually asymmetrical. We look like we're symmetrical, but we're really not. Everything's different from one side to the other side, slightly. Okay? But with these, they're exactly the same. You take a piece of paper, you fold it, and it lines up perfectly. Okay? So, that's an important fact. So, at this line of symmetry is what this is called. Line of symmetry. We want to know what's going on. Okay, where is it at? Right? Where is this perfect point? Well, in calculus, we use what's called the power rule to find these points, to find our maximums and our minimums. And think about that. What is this? This is a minimum. And this is a maximum. Because it gets to a max and then it goes back down. Another thing I want you to realize is that what happens here is things change. You go from a negative slope to a positive slope. What happens here is you go from a positive slope to a negative slope. But what happens before you go positive to negative or negative to positive? what do you have to meet in the middle of those? And let me help you. And if we remember the face, right? This is negative. This is positive. This is no solution. And this was 0. Okay? Alright? So, this face tells us a lot about this 0 slope. What happens is, when something goes from negative to positive, it has to hit 0 first. And when something goes from positive to negative, it has to hit 0 first. So if we had a method of finding out about its slope, it would really help us with curves. Well, that's what derivatives do in calculus. And so I'm going to teach you the power rule. Okay? And the power rule says this. You have y equals x to the a plus x to the b, right? Dot, 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 x. Or x to the 0, or something like that. So what you want to do is, and then you have these numbers out in front, that are your coefficients, which are, let's just say, capital A, capital B. Okay? And so what you're going to do is you're going to take your exponent, multiply it against your coefficient, and then subtract 1 from your exponent. So your first derivative is going to equal a times little a, and then a minus 1, plus b times little b times x to the b minus 1. And so on and so on and so on. And then at the end you'll have, x, so you'll have some number out here. It doesn't matter what number is out in front of x because it's 0 times that, right? And 0 minus 1, but it doesn't matter that it's to the negative 1 because what's 0 times anything? 0, and it goes away. Okay? So any number at the end is going to fall away. So let's do a derivative. So, and how we do it is we show it like y prime. And it's really simple. And we're only going to do this first derivative. It's really simple, and it's just 2 times whatever the first number is. So 2 times 1 is 2, right? Or in this case, 2 times negative 1 is 2. And what's 1 minus 2? 1. Right? So, there it is. And then what's 1 times 8? 8. And what's 1 from 1? 0. But what's x to the 0? What's x to the 0? 1. Right? So it just goes away. And then here you have an x to the 0, but 0 times 7 is 0. And 0 times x is 0. So that falls away. See how that works? So it's real simple. 2 times the coefficient. And I think the book might even give you an equation that says, okay, let's look at it as y prime is equal to ax squared plus by, or bx plus c, because we're talking about with just quadratics here, just quadratics. So what is, or that's what y is equal to. So what is y prime equal to? It's equal to 2a x plus b. That's it. 2ax plus b. Every time. 2ax plus b. That's it. That's all you're going to worry about for right now. When you get to calculus with me in a few years, then we'll worry about all the other stuff we can use this for and all the other rules that go along with the power rule. But right now, we're just using one little piece of the power rule to give us a real easy thing. And what this does is it tells us where the x value is, what the x value is for the line of symmetry. So, I'm able to say, okay, this is, in essence, the first derivative is the slope. The slope. So if I want to know a positive slope or a negative slope, I can find that out. But what slope am I really concerned with? Zero slope. So, that's why I take this first derivative and I set it equal to 0. Okay? That's it. You take your first derivative, set it equal to 0, solve. It's real simple. Minus 8, minus 8. Negative 2x equals negative 8. X equals 4. Okay? So they divide by negative 2, divide by negative 2, right? And I get x is equal to 4. Okay? What's y? Well, to find y out, I have to plug it into the original equation. But one thing I do know is that the line of symmetry is at x equals 4. That's where the line of symmetry is. Remember, back at the face, y equals a number, then it looks like the mouth. But if x equals a number, it looks like the nose. And that's why this line of symmetry is straight up and down. X equals 4. Okay? Alright, so what's y? And again, to find out y, I got to plug it into the original equation. So y is equal to 4 squared plus 8 times 4 minus 7.
It wouldn't be negative.
Sorry about that. Huh?
It wouldn't be negative 4?
Ah, negative out in front. Negative x. Because it's not, x isn't squared, right? It's negative x squared. The square only affects what it's directly next to. So, the negative's going to be out in front. Does that make sense? Alright, so then we got y is equal to negative 16 plus 8 times 4, which is 32, minus 7. So negative 16 plus 32 is 16, right? Yeah. Minus 7, so y is equal to 11. So, where is my point of symmetry at? The point of symmetry, the point at where I'm on a graph, is going to be the point of symmetry is 4, 11. Okay? Now, I'm going to take this to the next level.